Hello again, everyone. This is Mr. Vihil. Today we're going to be talking a little bit about direct variation. And we've got the definition of a direct variation right here. It's just a function of the form y is equal to k times x, where k is just some number. When you see a function like this, what we say is that y varies directly with x. There are other kinds of variations, but this is the first one we're going to look at, direct variation. And so one little quick example we're going to look at is y is equal to 5 times x. And first let's just look at a little table just so we get a feel for this thing. X and y, we'll let x be negative 3, negative 2, negative 1, 0, 1, 2, and 3. And for the y values, of course, we're just going to plug in these x values. So if x is negative 3, 5 times negative 3 gives us a y of negative 15. 5 times negative 2 would be negative 10. 5 times negative 1 is 5. 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. And 5 times 3 is 15. Just 7 quick points that we can look at. Now what we should notice here is, of course, that the y's are going up by 5 each time, as the x's are going up by 1 each time. So since we have this constant rate of change, this thing we know is going to be linear. And we should have noticed that a little bit just by looking at the equation. We just have x here. It's not raised to a power. It's not in an exponent. It's just multiplied by 5. We could have plus 0 written on at the end here, but we don't need that. But so this is a linear function, and of course we have this point right here, 0, 0, which is of course the origin. So direct variation, and every direct variation will be like that because 0 times anything is 0. So this is a linear function that passes through the origin. And that's another way of describing all direct variations. They're just linear functions that happen to go through the point 0, 0. And we could, of course, graph this thing. So why not? We'll just use our calculator here. Y equals, I've already got typed in there, y is equal to 5 times x. And we graph it, and sure enough, yes, it's a straight line, steeper than the parent function y equals x, which would be going at a 45-degree angle right here. And of course, it passes through the origin. So we're going to make a quick sketch, really simple, x and y axis. So y is equal to 5x is just this straight line that's pretty darn steep. Okay, so that's basically what a direct variation is. One other thing about direct variations is if we take this equation y is equal to 5 times x, and if we divide both sides by x, well, these x's over here are going to cancel out, and we have now y divided by x is equal to 5. So one way of spotting that something is a direct variation, and not just any linear function, is looking at the ratio of y to x. Like over here, the y is negative 15 when the x is negative 3. So negative 15 divided by negative 3 gives us this value 5, which we see up here too. That doesn't happen in linear functions that don't pass through the origin. And there's more to it than that, and we'll get into that a little bit more when we start talking about other linear functions. But again here, negative 10 divided by negative 2 is of course 5. Negative 5 divided by negative 1 is 5. 0 divided by 0 though, oops, there we have a problem. So this equation holds except when x is 0, because of course there's a problem with dividing by 0, which we'll talk about more a little bit later. But the same thing here still works over here. 5 divided by 1, 10 divided by 2, 15 divided by 3. All of those give us this value 5. So for a direct variation, if you want to look at it, if you just see a table, just look at the ratio of y to x. And that should be always the same thing. And this value 5 here, or in this equation of here, k, whatever that number is, that's called the constant of variation. That's that value k, in this case 5. One other thing here, if we also write this 5 as, say, 5 over 1, well, then we have what we call a proportion, which you studied a lot last year. Notice a proportion is, of course, just one ratio equal to another ratio. So another way of phrasing this is saying that y is directly proportional to x. Which means the exact same thing as saying that y varies directly with x. Same thing. Okay, well that's about it for direct variation. We'll get some practice with this in class, but I hope you took some good notes. I'll see you then.